Welcome. Modern large language models don't just split text on words. They use subword tokenization. Today we explore Byte Pair Encoding, or BPE, one of the most powerful tokenization algorithms powering GPT, Llama, and many other state-of-the-art models. Consider these 5 words: lower, lowest, newer, wider, newest. They share common character sequences. Instead of treating each word as one token, BPE finds and merges the most frequent character pairs. Notice the pair ER appears in lower, lowest, newer, wider, and newest. It is the most frequent adjacent pair. BPE merges it into a single token, Step 1. We initialize the vocabulary with every unique character found in the corpus. This small starting set can represent anything. Step 2. Count how often each word appears in the training data. Frequent words drive which pairs get merged first. Step 3. Represent every word as a sequence of characters, appending an end-of-word marker. This lets the model distinguish lower from low, followed by Step 4. Enter the main loop. We repeat the merge process until the vocabulary reaches the desired target size, typically tens of thousands. Inside the loop, Step 5. Scan the corpus and count every adjacent pair of symbols. The pair frequencies guide the next merge decision. Step 6. Select the pair with the highest frequency. This is our best merge candidate. Step 7. Merge every occurrence of that pair in the corpus into a single new token. Step 8. Add the new merged token to the vocabulary. Each loop iteration adds exactly one new entry. Finally, we return 2 artifacts: the learned vocabulary and the ordered list of merge rules, which together allow us to encode any new text. Let's trace BPE on 3 words. We start with every character as its own token, plus an end-of-word marker. Iteration 1. The most frequent pair is E, followed by R. We merge it into Lower and newer both benefit. Iteration 2. L and O appear together in both lower and lowest. They merge into low. Iteration 3. Low and W merge into low. Now, lower is just 3 tokens. Low, end of word. After these merges, our vocabulary has grown from pure characters to meaningful subword units. The model can now encode any unseen word by decomposing it into these learned pieces. BPE is everywhere. GPT models use it for English text. Llama and Mistral apply it for efficient multilingual handling. Roberta uses byte-level BPE to handle any Unicode character without unknowns. Multilingual models like XLMR share a single BPE vocabulary across over 100 languages. Beyond text, BPE tokenizes DNA sequences and source code. And historically, BPE was invented for data compression in 1994, only later adopted by NLP. Let's recap. BPE sits perfectly between character-level and word-level tokenization. It builds vocabulary bottom-up through iterative pair merging. A configurable vocabulary size controls the compression and expressiveness trade-off. It powers virtually every major language model today. And it gracefully handles unseen words, rare terms, and multiple languages. BPE. Teach a model to read, not just memorize. Thanks for watching.